Hello, students! So, in the previous lesson, we looked at the tables and graphs of proportional relationships. Another important way we can represent them is with equations, okay? And when you have a proportional relationship, the equation will always look like this. Y equals kx. Okay, where x and y are on the graph or in the table. And guess what k is? The unit rate. Okay, or our constant of proportionality, right? Same thing what we've been talking about. So let's go ahead and look at this problem about the deli counter. So it says, at the deli counter in the supermarket, Nigel paid $10 for 2.5 pounds of roast beef. The cost of deli meat is proportional to its weight. What is the equation for the graph of this proportional relationship? And you can see they've already given us y equals blank x. Well, guess what is going to go in that box? It's k. Okay, so all I really need to do in this problem, once I know what the problem's asking, is find the unit rate. Okay, no, it doesn't say find the unit rate, because they want you to realize that the proportional relationship equation will have the unit rate right there, always right there, the coefficient of the x. But let's go ahead and make this unit rate. So we know that $10 got him 2.5 pounds. And then to find the unit rate, I'm going to go ahead and divide. I'm dividing by 2.5 because I want to know the rate per 1 pound. Okay, so now I have 10 divided by 2.5. I'm going to go ahead and grab my calculator and do it that way. 10 divided by 2.5. And I'm getting 4. All right. That makes sense to me because, so this is $4 per 1 pound. $4 a pound for that ground beef. That makes sense to me because 4 times 25 would be 100. So 4 times 2.5 would be 10. But my answer here is going to be 4. This is one of your practice questions. Okay. And that's actually a really important idea. Y equals kx for any proportion. Let's do another one. All right. This one, we have Trisha's mom. She's asked her to fill up the car's gas tank and gave her $30. The graph shows the total cost of gas based on the number of gallons. The point X shows the number of gallons of gasoline Trisha can purchase. State to the nearest whole the number of gallons of gasoline she can purchase. Let me move this down a teeny bit. Oh, I see what's going on here. Hang on. I need to move this. All right. So let's take a look at this point X. Okay. If I follow it down to here, unfortunately, it's not falling very neatly on the grid lines. So it looks like a little less that, it's somewhere between 8 and 10. Okay. And then we can see that the Y value here is 30. And that's representing the $30. Okay, so I don't know where this point is. It's like 9.5 and 30 on the grid there. Okay, remember the X value is the number of gallons. So it makes sense to not have full gallons. Sometimes you don't get a whole gallon, you get part of a gallon, right? All right. So the question here says we need to find, state to the nearest whole the number of gallons of gas she can purchase. So what I would say here is that she really doesn't have enough money to buy the 10 gallons. Okay, so if we're going to state to the nearest whole the number of gallons she can buy, I can't say 10. So I'm going to go ahead and round this down to 9, meaning she can buy 9 gallons with $30. Then she might get a little change, right? She might have a little leftover. So the point here is that every point on the graph corresponds to a number of gallons and a price. So this one here would be like, I don't know, 1.8 gallons and $5. Okay. And that's how those graphs work. They always have an X value that represents one quantity and then a Y value that represents another quantity, another amount in the problem. All right, this is the last one I'm going to do. This is item 1 from your quick check. And in this one, I'm actually going to make a graph. All right. So here we have a coffee shop. And let me get the blue. Move me up here. At the coffee shop, the cost for using the internet is proportional to the time it's used. It costs $2 per hour to use the internet. Guess what that is? Select the graph drawn to show this relationship where X represents the number of hours and Y represents the cost. All right, so before I make the graph, I'm going to make a table. Okay. I know that if X is 1, Y is going to be 2 because they told me that. That's the unit rate, right? Here it is, unit rate. That is also K, the constant of proportionality. Okay, so remember Y equals KX. Okay, so that means for any X value, if I multiply 2 times X, I will get the Y value. Okay, so 2 times 1 is 2. I'm going to get some more points on here. I'm going to say, well, what if I use the internet for 2 hours? That's 2 times 2. I'm going to have to pay $4. What if I use the internet for 3 hours? That's 2 times 3. Okay, that means I'm going to pay $6. So this is the number of hours and this is the amount of money. And then I can graph those points. All right. They've told me what X and Y is. Guys, if you have time in a problem, people almost always put that on the x-axis because then when you read from left to right, you have this sense of what's happening as time goes by. Okay, 1, 2, 3, 4. And we can put time in parentheses, hours. All right, and then this is going to be the cost. If you can, on your graph, go by ones, okay? You're allowed to skip count by twos or fives or whatever, but it's just a little easier to see what's going on if you're going by ones. Unless the numbers get really big, then you're going to have to go by something else, of course. But here I can go by ones, so I should. Okay, my first point is x is 1, y is 2. That is here. Okay, next one. X is 2, y is 4. That's right here. Next one, x is 3, y is 6. Just like that. All right. And then I can connect those points to make a line. I'm a little scared to do that because I think I'm going to make it messy. So let me see if I have any line tools. Might have to just give it a try. Ah, no, that was awful. Did you see that? Oof. All right, let me try again. Oh my gosh, that was even worse. I don't know what's wrong with me, guys. But picture a line, okay, that goes through the origin and then through those points. Okay, how do I know it goes through the origin? Think about it. Okay, if X is the number of hours and Y is the amount of money, 0 hours means 0 money. If you don't use it, you don't have to pay for it. Okay, so look for a graph that looks kind of like that. And good luck with the rest of your work today.